This is Pre-Calculus section 10.2 Parabolas. This is video 1. The parabola is a collection of all points in the plane such that the distance from each point to a fixed point equals its distance to a fixed line. What that's talking about is this. Every point on the parabola fits this definition. The distance from each point, let's take this point right here, to a fixed point, and that fixed point is right here, that's called the focus. That distance right there from the point to the focus equals the point straight down to this line here called the directrix. Now they may not look like they are equal, but they are equal. That's the definition of parabola. That holds true for every single point on the parabola. Now there's some things that are also on this picture. The vertex is right here. In this case, it is the minimum. It is the bottom point of this parabola. The axis of symmetry is the line that goes through the focus and perpendicular to the directrix. It also goes through the vertex. Notice the focus and the vertex are on the same vertical line right there. The directrix in this case is a horizontal line down here. It is a distance A units away from the vertex. Notice from the vertex to the directrix is A units, and from the vertex to the focus is A units. And what that stands for is called the focal width or the focal distance. So A is the distance from the vertex to the focus. It is also the distance from the vertex to the directrix. Some books, instead of using A, use P. Last year's book used C, but this whole lesson is going to use A for this. Also remember that distance is a positive number. So let's look at some equations here. Here's the same picture right over there. This is what I call a vertical parabola because it is facing up. There are parabolas that face down. That is still considered a vertical parabola. We'll talk about the sideways parabolas in a little bit. The vertical parabola at the origin has this standard form. X squared equals 4ay. The vertical parabola where you've got it at vertex HK is this form right here. Now look at these two forms, very similar. The difference is you have H inside here with X. You've got K inside here with Y, kind of like we did with circles to find the center of the circle. This is the vertex of the parabola. Notice also in this format, the coefficient is with the non-squared item. The coefficient goes with the non-squared item. If A, this value right here, is greater than 0, the parabola will face up. If that A is less than 0, the parabola faces down. So for this form, we're looking at the vertex of HK. If it's this form right here, your vertex will be 0, 0, because it would be at the origin. If you can get the vertex, you can get the axis of symmetry very easily, because the axis of symmetry is this vertical line, x equals h. So if you've got the vertex, you automatically have the axis. Now the focus is located what I call inside the parabola, whether it's facing up or facing down. Pretend this is our parabola here. This would be the focus. So the focus is inside the parabola, and you find the focus by using this formula. It is h, which is that same h right there, comma k plus a. The directrix is this line that is outside of the parabola. In this case, it's a horizontal line, and the directrix is found by y equals k minus a. I know this sounds real confusing, but once we look at some examples, you should be okay. Two things to remember that might help you out. Once you look at the equation and you see there's x squared, you know it is a vertical parabola. If it's a vertical parabola, you are using this information right here to find the vertex, the axis, the focus, and the directrix. Also, so that you don't get confused with the horizontal parabola, which we'll hit a little bit later, it's this. To find the focus or the directrix, notice what we've done. We've added a to k, or we have subtracted a from k. And the reason that happens is because this is a vertical parabola. If it's a vertical parabola, then you make changes to the vertical part of the vertex. The vertex is hk. That is your vertical part. That is your y coordinate of the vertex. This is silly, but pretend vertical is spelled this way. Vertical, K instead of C, vertical. So if it's a vertical parabola, you are going to add it and subtract it to K. So let's look at an example. This says find the vertex, focus, directrix, and axis for each parabola. Before you get into all of this, you want to ask yourself, what kind of parabola is this? Okay, I look at this and I see that it's x squared, and that tells me that it is a vertical parabola, so just jot that down to the side, because identifying that it's a vertical parabola is going to help you out with how you find the focus and directrix. The other thing is, let's slide this over and line this up perfectly, and you see that x squared lines up, the y lines up, and the 8 lines up with 4a. That says it is very easy to find the a value. 8 equals 4a, divide by 4, a equals 2. So I jump down here and fill in the 2. I will need that to get my focus and directrix. Now go back to the vertex. Notice there's no parentheses, there's no x minus h or y minus k, so your vertex is 0, 0. Which means my axis is very easy. It is x equals that, 0. X equals 0. And the reason we're using that number right there is because that is the x coordinate of my vertex. Be sure you type or write in x equals 0, don't just put 0. Now the other thing I do here is, because I've identified it's a vertical parabola, I grab hold of this a and I draw an arrow to the y part of the vertex, like I just went over with you a second ago. Because it's a vertical parabola, the a is going to be tacked on to the vertical part of the vertex. So the focus is going to be 0, comma, 0 plus 2. That's what my formula says on the other page, which just gives me 0, comma, 2. To get the directrix, remember the directrix is a line, and it is the line y equals. It is a horizontal line. This letter and this letter are different. So your axis of symmetry is x equals, your directrix is y equals. So your directrix formula-wise will be the 0 minus 2. So your directrix is the line y equals negative 2. Now I know you weren't asked to graph, but a picture might help us a little bit. The vertex is 0, 0. Because this a is a positive 2, I know it opens up. So just making a sloppy little graph, I know my parabola looks something like that. It could be fatter, it could be skinnier. I'm not worried about that right now. My focus is 0, 2. So it's right there on that axis of symmetry. And my directrix is down 2 units. And there is my directrix. And that's the story for the vertex being at the origin. Now we're looking at one where the vertex is not at the origin. So let's line this up over here and see what's going on for naming the vertex. So that says x minus h squared, x minus 3. So the vertex is 3, comma. That says y minus k. We're going to look at this. To make this line up with minus k, I have to think about this as minus a negative, which gives me negative 1. Now you don't really have to get that fancy with this. The easy way to think about your vertex, just like we did with the center of the circle, is just opposite sign. That says x minus 3, that's why this became positive 3. That said y plus 1, that's why that became negative 1. Also, let's go back. Because it's x squared, this is a vertical parabola. Also, because this value here is negative, I know that my parabola is going to face down. Now the axis of symmetry, very easy. It comes directly from the vertex, x equals 3. Now to get our a, we're going to take this negative 2 and set it equal to 4a. So negative 2 equal to 4a. Divide both sides by 4 and reduce your fraction. A is negative 1/2. It is a vertical parabola, so this negative 1/2 is going to be put onto the vertical part of the vertex. So the focus is 3, comma, negative 1 plus negative 1/2, which is negative 1.5, which is negative 3/2. Math Lab is going to ask you to write those as improper fractions, not the mixed number. The directrix is the line y equals negative 1 minus negative 1/2. Minus and minus will be plus. Negative 1 plus 1/2 is negative 1/2. Little picture, over 3, down 1. I know it faces down. And where's my focus? My focus is at 3, over 3, down 1.5, which is there. And my directrix is this line real skinny up here near the x-axis. And that's two examples for a vertical parabola. Remember, two things that can help you out. One is, as soon as you see that this is x squared, you know it's a vertical parabola. Secondly, think about how you get your focus and directrix. Because it is a vertical parabola, the a value gets tacked onto the y part, which is the vertical part of your vertex. You will need to memorize this relationship. Focus is h comma k plus a, and your directrix is y equals k, or y equals k minus a. Now for the horizontal parabola, notice we have an a. It's the same idea. A is still the distance from the vertex to the focus, or the vertex back to the directrix. Just notice though that your directrix now is a vertical line because this parabola is opening sideways. So here's our two forms. If it's at the origin, it's y squared equals 4ax. If it's elsewhere, it is y minus k squared equals 4a times x minus h, similar to the last form. Notice the y is squared. The horizontal parabola has y squared in the equation. That's how you're going to know if you have a horizontal parabola or a vertical parabola. You have to look at what variable is squared. Y squared makes it a horizontal parabola. Also, if a is greater than 0, it faces right. So in this example right here, facing right, a was positive. And if it faces left, then the a must have been less than 0. Your vertex is still h comma k, meaning h comes from the x value over here, and y comes, your vertex is still h. Your vertex is still hk. Be careful, that means h is coming from this parenthesis with x, and k comes from your parenthesis with y. The order is backwards from what it was a couple minutes ago. Your axis of symmetry is easy to find, but it is y equals k. So if you can name your vertex correctly, and you think about what your axis of symmetry is, it is y equals k. Your focus is a similar set of equations, but because this is a horizontal parabola, then you make changes to the horizontal part of the vertex. So this a gets tacked on to the h. So you could think about h for horizontal, and the a gets tacked onto the h value to get your focus and your directrix. So that's two important things. The horizontal parabola has y squared in the equation, and to get the focus and the directrix, you're adding and subtracting the a from h. H for horizontal, h for that part of the vertex. So let's take a look at an example. This equation matches this equation. You see the y squared, you identify that as a horizontal parabola. We might as well think about that negative right now. Because that's a negative, we know this thing is going to face to the left. So I know my vertex because there's no h and k involved here. I know my vertex is 0, 0. So without doing a whole lot of work, I can make a sloppy little graph knowing that my parabola is going to face to the left and it has a vertex at 0, 0. I don't know how fat or skinny it is. That doesn't matter to me right now. I'm just getting a picture drawn, so that might help me with the focus and the directrix. Also, because it's facing that way, your axis of symmetry is this line. And what kind of line is that? That is a horizontal line, and that's why your axis is y equals that 0, because it's the x-axis in this case. To get a, I should line up 4a with negative 28 and solve that equation. 4a equals negative 28 divided by 4, and a equals negative 7. So, to get the focus and directrix, this is a horizontal parabola. The a is going to get tacked onto the x part, the first part of the vertex. So the focus is 0 plus negative 7 comma 0, which equals negative 7, 0. The directrix this time, the directrix, because it's facing this way, the directrix is out here somewhere. That is a vertical line. Vertical lines are of the form x equals something, minus negative 7. Minus and minus makes a plus, so I have x equals 7. So you can look at the sloppy little picture and see if this kind of matches. I've got a focus of negative 7, 0. So there's my focus right there. Your focus is inside the parabola. and your directrix is out here 7 units. I didn't quite count all the way out to 7, but that's the idea. There's your focus, there's your directrix. This is a distance of 7. This is a distance of 7. Doesn't look like it because it's not a great drawing. All right, how about a horizontal parabola that's not at the origin? So we can name the vertex and be careful about the order. It has to be what's with the x, changing the sign, -1, comma, what's with the y, change the sign to a +5. This is a horizontal parabola, and I know it's a horizontal parabola because the y is squared. I also know because this number right here is positive that it faces to get the axis of symmetry. Because this is a horizontal parabola facing to the right, -1, 5 up here somewhere, facing to the right, looks something like this. The axis of symmetry is this kind of line, which is a horizontal line, and it's y equals the 5, which is the horizontal part of the vertex. To find a, I just have to set 8 equal to 4a. 8 equal to 4a, divide by 4, a is 2. Because this is a horizontal parabola, the 2 is going to be added and subtracted from the x part of the vertex. So the focus is -1 plus 2, 5, which is 1, 5. My directrix is going to be a vertical line, and that's x equals -1 minus 2, which is -3. So picture